7.2. This is very similar to things we've done before. So what we're doing here is pretty much finding integrals as normal, and then we plug in an initial condition to find a particular solution. So instead of the plus c, we're going to find out what that c is. So if you take the integral of both sides here, well, the integral of this derivative, that's just y, is equal to integral of e to the 2x minus 2x squared dx. And make sure you're writing small in this lesson. So to find the integral of e to the 2x, you have to use u substitution. U equals 2x, du is equal to 2 dx. So du divided by 2 is dx. So y is equal to the integral of e to the u, and that's a du over 2, minus, I'm just splitting these integrals up into 2. We didn't use u sub for this right integral here, because you can separate them if you have a subtraction or an addition. So now we just find the integral here. Y equals, well, being the one half out front, the integral of e to the u is just e to the u. And I'll just write the 2x right there. So e to the 2x is that first integral there, minus 2 times, this is a reverse power rule, 2 plus 1 is 3, and you divide that by the 3. And now you plus c. So this is our general solution. Now we have to find the particular solution with our initial condition. Y of 0 is equal to 4. So this is just 0 comma 4. X is 0, y is 4. So you plug these in, right? X is 0, y is 4. 4 is equal to 1 half e to the 2 times 0, which is 0, minus, well, 2 times 0 cubed divided by 3, that's just 0, plus c. And then 4 is equal to 1 half, because e to the 0 is just 1, so 1 half times 1 is 1 half, plus c. So that gives you a value of 3.5 equals c. Once you have the c, you just plug this into your general solution. That gives you your final answer. So y is equal to 1 half e to the 2x minus 2/3 x cubed. Instead of plus c, it's plus 3.5. That's your answer here for question 1. So question 2. This problem is actually the same exact thing. It's just worded a different way. On the AP exam, you might see questions that kind of look like it's new, but it's just what you already know. So a curve has a slope of e to the 2x minus 2x squared. So dy dx is slope. At each point x comma y on the curve, what is an equation for this curve if it passes through the point 0 comma 4? So again, question 1 and 2 are the exact same thing. They're just worded differently. So if d squared y over dx squared is equal to 1 over x squared plus 1 minus 2x squared, find the particular solution of y if y prime is equal to 7 over 6 and y1 is equal to 0. This is going to be a really long problem. Be sure you are writing small here. So if you take the integral of the second derivative, that gives us the first derivative. So dy dx is equal to, let me rewrite this here. So the integral of 1 over x squared, that's x to the negative 2. And to find this, we have to use u substitution again. So if u is equal to 1 minus 2x, du is negative 2 dx, so then du over negative 2 is equal to dx right there. So that's the integral of u squared times du divided by a negative 2. So next line here, let's find these derivatives. dy dx is equal to, you do a reverse power rule. X to the, you add 1 to the power to negative 2, so it's x to the negative 1 over negative 1, and then you subtract. So let's bring the negative 1/2 on the outside. Now the integral of u squared is you add 1, so it's 3 over 3. So it's negative 1/2 times u cubed over 3 plus c. So this is where you just plug in this first initial condition. So when x is 1, dy dx is 7 over 6. So dy dx is 7 over 6 equals, plugging in the x for 1. So that's negative, well, x to the negative 1, that's just 1 over 1 minus 1/2. So remember, u is 1 minus 2x. So it's going to be 1 minus 2 times 1, which is just 1 minus 2 cubed over 3 plus c. So if you simplify all this, if you end up simplifying this mess, you figure out like what this is equal to, add it to the other side, you end up getting c is equal to 2. I'm going to skip all this. Our first c is a 2. So we can now plug the c into our first derivative right here. So dy dx is equal to, well, negative x to the negative 1 over negative 1 is negative 1 over x minus 1/2 times 1/3 is 1/6. The u cubed is 1 minus 2x cubed. Instead of plus c, it's a plus 2. So here is where we find the derivative, I mean, not the derivative, the integral again. So the integral of the first derivative is just y is equal to the integral of negative 1 over x is just negative ln absolute value of x minus, so to find this integral, you have to use u substitution again. So you can try that on your own, but you should get 1/6 times 1 minus 2x, raise that to the 4, over 4, but then you have to multiply by 1 over the derivative of 1 minus 2x, which is negative 2. Integral of 2 is just 2x, and then you plus c. So, yeah, this is kind of a mess. Well, as long as you understand the process, that's the key thing here. So, now we have y of 1 is equal to 0. So that's oops, that's not a 0, comma 1. That's a 1, comma 0. When x is 1, y is 0. Let's plug these all in. So y is 0 is equal to negative ln of 1 minus 1/6 times, that's just 1 minus 2 to the 4th over 4 times negative 1 over negative 2. 2 times 1 is just 2 plus c. So again, I'm not going to save, sorry, this is a 4 here. It's kind of hard to see. That's a 4. So again, I'm not going to spend this time on the video doing all these computations, but if you isolate the c, like simplify all this, move it to the other side, you get a c value is equal to negative 97 over 48, which is just a little above, below negative 2. Now you plug the c value back into your equation here. So y is equal to negative ln absolute value of x. So negative 1, 6. So it's 6 times 4 times negative 2. That is a negative 48, and it's a minus sign. So plus 1 over 48. 1 minus 2x to the fourth power. It should be a 4. Plus 2x minus 97 over 48. That is your answer right here. A lot of algebra. So, this is to recall. The derivative of sine x is cosine x. However, the integral of sine x is going to be negative cosine of x plus c. Because the derivative of cosine x is negative sine x. Integral of cosine x is positive sine x plus c. Again, because if you take the derivative of sine x, you get cosine x right here. If you take the derivative of negative cosine x, you get negative negative sine x, which is a positive sine x. This is something that students are easily confused with, so make sure you do not accidentally get these wrong. This question right here, for what value of k, if any, will y equals ke to the negative 4x minus 2 sine of 5x be a solution to the differential equation, this right here? So, when you see a question like this, you see here we have to find the second derivative, so let's just find the second derivative for now. But first we have to find the first derivative. So y prime is equal to, this is where you use the chain rule, negative 4k e to the negative 4x minus 10 cosine of 5x. That's the first derivative. Second derivative is equal to, well, we have to use the chain rule again, 16k e to the negative 4x, and then it's adding 50 sine parentheses 5x. Again, if you're confused with how we got these derivatives, please pause the video right now and ask your teacher or a classmate for help. So now we have the second derivative. We can plug the second derivative into this equation, this differential equation right here. So y double prime is just what we just calculated right there. 16k e to the negative 4x plus 50 sine of 5x. Now plus 25y. Y is what we have right here. So it's plus 25y, which is parentheses k e to the negative 4x minus 2 sine of 5x equals negative 82 e to the negative 4x. So this kind of looks ugly right now, but you'll see later things will cancel out very nicely. So let's get rid of this parentheses here first. So 16k e to the negative 4x. Oops, that was sloppy. 16k e to the negative 4x plus 50 sine of 5x. So you have to multiply 25 by everything inside the parentheses. So that's a plus 25 ke to the negative 4x minus 50 sine of 5x equals negative 82 e to the negative 4x. So if you see here, the 50 sine of 5x cancels out with the minus 50 sine of 5x. And then now, you see how you have a 16ke to the negative 4x and a 25ke to the negative 4x. You can combine those since they all have the same, well, variables here. So that is a 41. On the left side of the equal sign, it's a 41ke to the negative 4x. And on the right is just negative 82 e to the negative 4x. You can see there's an e to the negative 4x on both sides, so those cancel out. And now you're just left with 41k is equal to negative 82. So you divide both sides by 41, and you just get k is equal to negative 2. That's your answer. A lot of algebra in this one. If you need help, please let your teacher know.